Alright, good day everyone. You are welcome to our channel. Today we'll be looking at addition and subtraction of algebraic fractions. This is a continuation of the video we've started on algebraic processes. I believe we have watched those videos, and if you are yet to watch them, please kindly just go to our channel and avail yourself with the relevant videos that we have done so far. Alright, without wasting much of our time, we'll be looking at how to add algebraic fractions and also how to subtract them. So whenever we are confronted with questions that is peculiar to a given fraction, how do we handle them? What is going to be the best approach to them, and how are we going to attack it with the maximum knowledge applicable? So we'll be exposing us to different questions, and we believe that by the time we solve 2, 3, 4 or more questions, we are going to gain mastery, and every other areas where we are having confusion will be dealt with. All right, now let's just go to some questions. This is question 1. This is a typical example of a fraction, an algebraic fraction. Just like we've said earlier, how to identify algebraic fractions, we said that one of the ways you will know an algebraic expression is you will see letters being added to them, just like as we have 4a plus 13 divided by 5 minus 2a plus 3 divided by 3. Alright, so this is a typical algebraic fraction. So how do we solve problems like this? Alright, so it's very easy. Just like in our elementary mathematics, when we're in primary school, we are exposed to fractions. For example, something like this. Maybe we must have done something like this before. Alright, so whenever we are confronted with this, what we normally do is to find the LCM. Okay, so we'll find the LCM. So what's going to be the LCM of 3 and 2? So when we talk about LCM, we are simply asking that what are the numbers that 2 and 3 can divide without a remainder. So that's going to be the multiple. We talked about lowest common multiple, and we are interested in the lowest one. For example, let's try and list some of the numbers that 3 can divide without a remainder. Just like in our multiplication table, we have 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and so on. Alright, let's look at numbers that 2 can also divide without a remainder. We have 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and so on and so forth. So when are we to stop? You simply stop when you can see a common factor. You see, this particular one is common, number 1, and is the lowest because it's the first of its kind that we can see as we follow this sequence. So we say that the lowest common multiple of 3 and 2 is 6. Why? Because that's what is common, and that's the first one we can see. So you agree with me that this is going to be 6. And now what do? We now use this 3 to divide this lowest common multiple that we have. So it's going to be, we look at the denominator, we have 6, 3, we are going to say 6 divided by 3, and that's going to give us 2. So whichever answer we get, we are going to use it to multiply the numerator. So it's going to be 2 times 2, which is going to be 4, plus 6 divided by 2 is going to be 3. 3 times 5, that's going to give us 15. So by the time we add up the numerator, we are going to have 19 divided by 6, which we can also break down to mixed fraction. I believe we are understanding this. This is not a big deal at all. So 6 times 3 is 18, so it's going to go 3 times, remainder 1 over 6. So this just a refresher course on how we normally handle fractions while we were very tender in school. All right, so it's the same approach we are going to use for this. The first thing to do is to find the LCM. Now, what's going to be the LCM of 5 and 3? That is the lowest common multiple. So we are simply saying that what are the numbers that 5 can divide without a remainder, numbers that 3 can divide without a remainder. By the time you check through them, then you find the lowest one that is common to the both of them. Then that will be the LCM. All right. Apart from listing like this, another way people normally do it is just to multiply this and this together. They just say, well, so 3 times 2, 6. The issue about this is that most of the times it's not going to give you the lowest. Sometimes you may not have the lowest common multiple. So that's why it's good to, but whichever case we decide to do, when you do one that is not the lowest, that means when you get to your final answer, you'll be required to simplify to the lowest term. All right, so let's take the approach. I know that this is 5 times 3. That's going to give us 15. Of course, this is going to be the LCM. All right, so 15 divided by 5 is going to give us 3. So we're going to use this 3 now to multiply the numerator. So let's put it inside a bracket like this. Repeat the negative sign. 15 divided, then you use this 3 now to divide this 15. So 15 divided by 3 is going to give us 5. So we have 5 into 2a plus 3. Okay. All right. So what do we do now? We let me shift this down way. We open this bracket. We remove the bracket by using 3 to multiply everything inside. So we have 12a. That's 3 times 4a. Then plus, we also say 3 times 13. That's going to give us 39. Okay. Then negative minus 2 times 2, 5 times 2a. That's going to give us 10a. The minus, you be careful with the sign. This very sign in front, we affect the sign here. So we are going to see these two signs multiplying each other. So we have negative multiplying positive, and of course it's going to give us negative. So that's why we're having this negative. Then 5 times 3, that's 15. Okay, then everything divided by 15. So what do we do next? We collect the like terms at the numerator. So all the ones having a, we bring them together. I can see 10a. Then plus, I can see 39 minus 15. Okay, everything divided by 15. All right, so if we do this, what do we have? 12a minus 10a is going to give you 2a. Please, I want you to watch our video. There is a video we've done on how you can easily do this. Subtract them. Please try and watch that video. It's going to help you a lot. So that in case you are not understanding what we are doing, by the time you watch that video, it's going to help you to understand how you can subtract these algebraic expressions like this. All right, so plus 39 minus 15. Just like the illustration we normally give. Your positive means you use your money. Negative means you are owing. So you have 39, you are owing 15. So when you pay your 15, how much are you going to be left with? Of course, that will be positive. If you take that from that, that's going to be 24. Okay, that's 24. All right, so we have, this is 15. That's 4, 1. So we have 24 divided by 15. Okay, or we can simply simplify there. I can see 2 that is common there. I can bring 2 out and say a plus 12 divided by 15. And this is going to be the final answer. I believe we understand this. There's no big problem about this. It's very simple. Just follow the maths, follow the procedure. Thanks for watching this. We are going to go to the next question now. Please, I want to beg us to please subscribe, share, and like. As you are doing that, you are encouraging us to do more. And also when you subscribe, anytime we post another video, you will be able to see it and also learn adequately. So thanks for watching this. Let's take another question so that we may be able to gain mastery as we progress further. Thank you. All right, welcome. This is question 2. We will be looking at this. How do we solve problems like this? Is another algebraic fraction, and we are asked to simplify. Okay, so let's just get down to this. How do we simplify algebraic fractions like this? Okay, so we have 7. We have to simplify 7 divided by 3a minus 6 divided by 5c. Just like what we normally do, we do say the first thing to do is to find the LCM. In this case, you will see that letter has been mixed with it. All right, so there is no big deal about that. Just focus on the constants. We have 2a, we have 3a, and we have 5c. All right, so put your eye on the constants. Just like, we have 3 and we have 5. So we normally multiply them if this is the approach you want to do. Okay, that's going to give us 15. Then repeat the letters. That's as simple as that. That's going to be the LCM. So this is going to be the LCM of that. So when you focus your attention on the constants, when you multiply them, then just use this the letters and just repeat them. This is to multiply whatever you have gotten. All right, so if I do that, I'm going to have the LCM of this to be 15 AC. Okay, so now what do we do next? You'll be using this denominator to be dividing the LCM we have just gotten. So let me just show us this way. We have 15 AC divided by 3a. All right, so a we cancel a. 3 here 1, 3 in 15, that's 5. So I am left with 5c. All right, so that means here will be 5c. Then multiply by 7. Just focus on the constant. 7 times 5, that's 35. So we have 35c minus. All right, so then again we have 5c. So you are going to say 15 again. You'll be dividing the lowest common multiple, or their LCM, by the denominator of in each case. So we have AC divided by 5c. So c we cancel c. Then 5 here 1, 5 in 15 is 3. So we have 3a left here. All right, so and 3a now we multiply 6. So just say 6 times 3, that's 18. So you have 18a. Okay, so as you can see, this is what we have. I can't see any common factor here. So this is going to be the answer to this. I believe we enjoyed this. There is no big deal at all. It's very simple. Let's look at another question. Yes, this is another question that we are asked to simplify. Okay, this is another typical example of algebraic fractions. In this case, we are to simplify 1 over 2 multiplied by 3x plus 1 plus 1 over 3 multiplied by x plus 2. All right, so it's very simple. There is no big deal. I want you to know that there is this thing they normally do in mathematics that used to get students confused. When they see something like this, they begin to wonder, how do I do this? No, it's the same thing as saying x over 2, x plus 2 divided by 2. It's just like that. So you don't need to begin to wonder, how do you express this? So it's just this way. They just decided to do that because what happened is they're actually multiplying each other. So in essence, we have 1 over 2 is multiplying x plus 2 over 1. So numerator multiplying numerator, now we are going to have x plus 2 divided by 2 times 1 is going to give you 2. So can you see, there is no big deal at all. So that's what we are going to do here. That means what we have here is 3x plus 1 divided by 2 plus x plus 2 divided by 3. Alright, so what do we do next? We find the LCM. The LCM is going to be 6, of course. When you divide 6 by 2, you are going to have 3. So we have 3 into 3x plus 1 plus 2 into x plus 2. Alright, so let's just go further. Let's simplify this by removing the brackets. So we are going to have 3 times 3x. Just focus on the constant. That's 9. Repeat the letter. Then 3 times this is going to give you 3 plus 2x plus 4. Alright, then everything divided by 6. So when you do this simply, we now collect like terms at the numerator. So we can see 9x plus 2x plus 3 plus 4 divided by 6. So when you simplify further, 9x plus 2x, that's going to be 11x. Then 3 plus 4, that's going to give us 7, all divided by 6. Alright, and this is going to be the final answer. I believe this is not a big deal at all. We are really understanding this. Let's also look at another question. Okay, this is another one. Here we are also to simplify, but in this case you see that we have about 3 sets adding and subtracting one another. There's no big deal at all. How do we get the LCM of this? Usually when you have an algebraic expression like this, you simply just have all the denominators to be the LCM. So what do I mean? If I find the LCM of this now, each of them is going to be n minus 6, n minus 4, n minus 5. So you just, the 3 denominator of this kind is going to be the LCM. Alright, so how do we do this? We simply, just like the way we normally do, this n minus 6 is going to divide everything. So just let me show us this. We have n minus 6, we have n minus 4, and we have n minus 5 multiplying each other. Now you are dividing by the first denominator here, which is n minus 6. Okay, so what do we do? You see that since this one are multiplying, this will cancel this. So you are left with the other 2 brackets. So that's just the sequence. So what I'm going to write now, I'm multiply by 1. So it's going to be the same. So that I'm going to have n minus 4 and n minus 5. Alright, we drop down your positive sign. That in this case now, it is minus 4 that is going to go out. The other 2 will remain. This and this will remain. Multiply by 1 is still the same. So I'm going to have n minus 6, n minus 5. Alright, then minus now, because I repeat that sign. Now in the case of n minus 5, that means this one will go. It's only these 2 that will remain. So multiply by the numerator, which is 2. So you have to, I would like us to put this rectangular bracket, so that because of this negative, so that it can have its effect. So we are going to have, in this bracket now, we are having n minus 6 and we are having n minus 4. So we close this, then we have this. Alright, so we'll quickly go further. Just like when we are dealing with expansion, please, we have done a video on expansion. Kindly just go and search for that video so that you can understand how do we expand brackets like this. So please, this is n times n, which is n square. N times minus 5 will give us negative 5n. Minus 4 times n will give us minus 4n. And minus 4 times minus 5 will give us positive 20. Alright, we are done with that. Plus, in this case also we have n times n, that's n square. N times minus 5 will give us minus 5n. We are through with that n. Then we take minus 6. Minus 6 times n will give us minus 6n. Then plus 30. 5 times 6 is 30. So we have negative, then 2. Now inside this bracket now we have again n times n is going to give us n square. N times minus 4, we have minus 4n. Then we have minus 6 times n is going to give us minus 6n. And minus 6 times minus 4 is going to give us plus 24. Alright. Everything here now is a very long one. Is divided by the 3 brackets. Alright, so what do? We simply collect like terms. We still have this particular area to deal with, so let's just finish with that. Let's quickly finish with that side. This is this minus 4n plus 20 plus n squared minus 5n minus 6n plus 30. Then the negative 2 is we start opening that bracket now. So we have minus 2n squared. We have plus 8n. Okay, that's 8n. They also have plus 12. That's plus 12n. Then we have minus 24. Okay, if we do that properly. You have to be very careful when doing this, because any little mistake in the sign or in the multiplication will just render the whole answer wrong. We make it to be wrong. So when we collect like terms, we are going to have n squared. Okay, I can see another n squared here. All the ones with n squared. This is plus n squared. Okay, is there any other n squared? Yeah, I can see another one there, minus 2n squared. All right, I'm through with n squares. Let me now go to n. I can see negative 4n. Okay, negative 4n. I can see negative 5n. I can see negative 6n. Okay, I can see positive 8n. I can also see positive 12n. All right, so this is how to collect like terms. Then let's look at the constants now. I can see positive 20. I can see positive 30. I can also see negative 24. All right, so be sure you've not leave anyone behind. Usually I do count. Whenever I have long expressions like this, I count to be sure none have been left behind. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, then the one I gathered together, I see also up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see, something is missing. That's why it's always good to double check, especially when you are dealing with this. So let's see which one is missing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So one of them have not been considered. Okay, I think this, I can see it here. This was missing, this very one, because there is a repetition. I have minus 5n, and I can see also minus 5n. From what I collated together, I only have a single minus 5n. So it's always good you check. Very, very good you check. So let me just introduce it here. There's minus 5n here. All right, this will help you, and especially when you have long algebraic expressions like this. It's always good you do that counting to be sure that none of your term or representation is left behind. Okay, so this is what we have. Now we are going to go to another page there where I'm going to now simplify finally, and then we see this final answer to this. I believe we are enjoying this video. I believe there is no question. Please, if you have any question, kindly drop in the comment section, and follow us gradually even as we progress step by step. Thank you for watching. So let's just go to another page now as we complete and finalize on this one. Okay, before we go to the next page, I simply want us to, because transferring this may be too long for us, Let's just simplify a little here. Let me use a different color just to reduce the length then, so that we can now transfer. Now this is n square plus n square. Of course, that's going to give us 2n square. That's going to give us 2n square. Then we have excuse me, minus 2n square. Okay, that means we've taken care of that. Of course, this is going to give us 0. 2n square minus 2n square, that's 0. Please, if you are finding it difficult to understand, kindly watch the video we have done on that. If you bring out what is common to this 2 is 2n square. So if I bring out 2n square and I divide each one by 2n square, I'm going to have 1 minus 1. And of course, 1 minus 1 is 0. So multiply by 2n square is going to give you is 0. So that's why this one is 0. From here to here is already 0. Now we are here now. We have minus 4n, minus 5n, minus 6n, minus 5n. Can you see? So minus, minus, minus. Let's join them together. Minus 4, minus 5, that's minus 9. Minus 9, minus 6, minus 15. Can we see now? Minus 15, minus 5, minus 20. So you see we have minus 20n here. All right. Then we now have positive n, that's 8n, and positive 12n. So 8 plus 12, that's 20, right? Good. So we also have 20 here, which is positive. So this is plus 20n. Can you see? The same thing, different sign. So what do? They will also cancel out. This is also 0. Minus 20n plus 20n is going to give us 0. So you see, that means from here to here, you can just inspect it yourself. This is minus 4, minus 5, that's minus 9. Minus 9 minus 6, minus 15, minus 15, minus 5 here, minus 20. Then 8 plus 12, that's 20. So you see, both all of them in like term, n, having a common letter n. So you see, we have minus 20n and we have minus plus 20n. So that's going to give us 0. All right, so we are left with the constants now. The constant side, we have 20 plus 30, which is 50. All right, then 50 minus 24. This is what we have. I don't know where we are understanding this matter. This math, they end up canceling out one another despite how long they are. So how do we do this? This is what we do. It's remaining 1. This is just a refresher course. That's 6. Then this is going to give us 26. So you see, we are able to have 26 here. And we are going to have our n minus 6, n minus 4, n minus 5. In fact, you can arrange it 4, 5, 6, depending. But we have 26 above. So our final answer, maybe we can even give our final answer here without going to another page, since we can have a little space here. I believe we are understanding it. Please, if this we are getting confused, please kindly pardon me. Transferring this long thing to another page may not be quite easy. That's why, so that I will not miss out any of this expression again. That's why I just decided to just fix it up here. All right, but I believe we are understanding the way we are handling it gradually. The numerator now, what we have finally there is 26. That's what we have at the numerator after subtracting 24 from 50. Okay, so but at the denominator we have our LCM. Okay. All right, so we can actually leave this solution like this. Can actually leave it like that, and that's a good one. Some people may say, why not let's expand this bracket? Well, it depends on how the examiner wants the solutions to be, but I believe this is good enough, because even if you expand this, it's not that you are going to see other factors that you can do use it. We just have constant at the numerator direct, so I think this is good to go. One of the things I also want to stress is this area that you have to be very careful. the bracket inside here is very sensitive, and be very careful to just put a rectangular bracket there, so that by the time you finish with these two brackets, whatever is remaining, whatever you are able to get, then you can use this -2 to multiply through, and that's what we did. We're able to have n squared minus 4n minus 6n positive 24. All right, because minus 6 times minus 4 is going to give us a positive 24. I believe we have enjoyed this video. Let's see another question. Now look at this. This question is actually more of an application question, but it's also something very important that we must take note. All right, the question is asking us to if x is 2a plus 3 divided by 3a minus 2, we are to express x minus 1 divided by 2x plus 1 in terms of a. All right, so what do? We simply look at what the examiner has defined. Okay, so let's see what the examiner is saying. X is this, so wherever we see this x, he said it is equals to this. So this x is equal to 2a plus 3 divided by 3a minus 2. So this is what we have. All right, so now in this expression, anywhere we see x, we quickly we substitute this into it. All right, if we do that, we are going to have x like as I have in the numerator here. Instead of him to write that x, I'm going to have 2a plus 3 divided by 3a minus 2 minus 1. Okay, that's numerator divided by 2, another x, that's 2a plus 3 divided by 3a minus 2, then plus 1. Okay, I think we are understanding this. So this is what the examiner is just trying to let us know, that okay, I've defined my x to be this, so express this in terms of a. All right, so I think it's better for us to take it one after the other. Let's look at the numerator. So when we simplify the numerator, then we now come and look at the denominator again. So the numerator is 2a plus 3 divided by 3a minus 2 minus 1 over 1. So it's the same. Okay, so what do? We find the LCM. So let me transfer it up here. Let me just divide this. Okay, so we have 2a plus 3 divided by 3a minus 2 minus 1 over 1. The LCM, of course, is going to be 3a minus 2, because even if you multiply this and this together, you are still going to have 3a minus 2. So when we do this, we are going to, this divided by this guy is going to give us 1. So we have 2a plus 3 minus 1 divided by this is going to be this. So we are going to have 3a minus 2. All right, I'm going a little bit faster now. I'm believing we should be gaining mastery. So we have 2a plus 3. This negative will open this. We are going to have minus 3a plus 2. Okay, everything divided by 3a minus 2. All right, we simplify the numerator now. This is going to give me 2a minus 3a. That's going to give you minus a. Then 3 plus 2, that's 5. Then divided by 3a minus 2. Or you can write it so that I don't like this negative coming showing like this, so I can make it 5 minus a divided by 3a minus 2. All right, this is what we have for the numerator. So let's look at the denominator. Trying to okay, denominator now. Okay, so let's see what was the expression there. What we have here is 2 into 2a plus 3 divided by 3a minus 2, everything added to 1. All right, so this 2 is going to multiply. This is like 2 over 1. So numerator will multiply numerator, denominator will multiply denominator. So by the time you use this 2 to multiply this numerator, you are going to have 4a plus 6, all right, divided by 3a minus 2. Okay, I think 1 was minus. Okay, yeah, we have dealt with the one with minus. So we have plus 1 over 1. All right, so again, we are going to find the LCM. The LCM is going to be the same, 3a minus 2. This in this is going to be 1. 1 times this is going to give us 4a plus 6 plus. Then, of course, 1 divided by this is going to give us 3a minus 2. So 3a minus 2. Yeah, what I mean is this denominator divided by 1 is still going to give us the denominator. Okay, so when we do that, when you simplify, we are going to have 4a plus 6, then plus 3a minus 2 divided by 3a minus 2. All right, so if you simplify the numerator very well, this is 4a plus this, that's 7a, then minus 4 divided by 3a minus 2. All right, so this is what we have. So what do we do now? We combine them together. Let's combine everything now. Numerator upon numerator, denominator upon denominator. I believe this is we are understanding the way we are getting along with this solution. So please, let's just quickly combine them. The answer we got for our numerator happens to be this. All right, so let's bring it. So we have 5a. Okay, let's just say 5 minus a divided by 3a minus 2. Okay, so divided by what we have at the denominator is 7a minus 4 divided by 3a minus 2. So what do we have? We have 5 minus a divided by 3a minus 2 times, of course, it's going to take the reciprocal form. The reciprocative form is what we are going to have. I believe we still remember this in our elementary fractions. When division sign changes to the multiplication, the denominator becomes numerator, numerator becomes a denominator. So when you see clearly, you see that this can cancel this. Then finally we have 5 minus a divided by 7a minus 4. And this is going to be our final answer. I believe we enjoyed this video. I believe this solution is clear. And please, let's see if you have any comments. Please kindly drop in the comment section. And I think this solution is explicit enough. If you follow it step by step, if you have any, I believe everybody should have the idea on how to divide algebra now, and also how to do some simple arithmetic as regards algebraic expressions. So thank you for watching this this video. I believe it has been educative. Please kindly share to, you can also help somebody by sharing the link, and as you do so, God will bless you, and you have also encouraged us. All right, see you in our next video. Thanks for watching. Bye for now.